Find the range of the following functions. So we've got f of x is 2x minus 3 with a domain of from minus 1, 0, 1, 2, 3. G of x is x squared minus 2 with a domain from x belonging to real numbers, x being between minus 4 and 4 inclusive. And h of x is equal to 1 over x squared domain, x belongs to a set of real numbers between 0 and 4, not including 0, but we can include 4. State whether the functions are 1 to 1 or many to 1. Right, so if we got f of x is equal to 2x minus 3, and here we've got a finite number of elements. All right, so we are going to draw a mapping diagram. So drawing a mapping diagram, so this bit here represents the domain. So we've got minus 1, 0, 1, 2, 3, the numbers we got from here. If we substitute minus 1 into here, we get 2 times minus 1, minus 3, which is minus 5. Similarly, putting 0 in there, we'll get minus 3. Putting 1 in there, we will get minus 1. And putting 2 in there, we'll get 1. And putting 3 in, we're going to get 3. So we can say that the range of f of x is also finite, which is minus 5, minus 3, minus 1, 1, and 3. Okay, and we can very, very clearly see that this is a 1 to 1 type of function. Part B, we've got g of x is x squared minus 2 from x being from minus 4 to 4. This is infinite number of values here. Okay, so therefore we need to probably sketch a graph. So if we sketch a graph, it's y is equal to x squared, that move down 2 units. Right, it is defined from minus 4 to 4. So if we put circles in, closed circles in there, and we call this bit here is the domain, but what we're interested in is the range. We'll be a little bit careful here. The lowest value that this can ever take between minus 4 and 4 is minus 2, this point here. And the highest value that it can take, if you put 4 minus 4 in here, you get 16 minus 2, which is 14. So this bit here is called the range. So we can say that the range of g of x is from minus 2, and we put the term g of x in here, not x, okay, so we need to put g of x here less than and equal to 14. It can be equal to because here it is equal to and equal to here. Now this function is what's known as a many to 1. If we take minus 4 for example, minus 4 maps on to 14, and then also 4 maps onto 14. It only has to happen once for the function to be determined many to 1. C, we've got h of x is 1 over x squared. So this is the part of f of x, h of x is 1 over x squared. And it's defined from 0. It can't be defined at 0, because if you put 0 in here, you get 1 divided by 0. So actually, this line would act as what's known as a vertical asymptote. But for it is fixed. Now, if you do 4 in here, 1 over 4 squared is 1/16. So here is the domain. The domain is not equal at 0, so therefore we have an open box here, but it is equal at 4. Okay, so therefore this point here will be a closed circle, and the range will go upwards here, and the arrow indicates that it carries on forevermore because this line acts as an asymptote. So this is the range. So this time we just write down the range of h of x is greater or equal to 1/16. It can be equal to because at this point the domain can be equal to 4, so you can put 4 in there. Now this is a 1 to 1 function as well. Okay, so this has been a video to show you how to find the range of different types of function. I hope you've understood, and I thank you very much for watching.